Good morning, good afternoon, good evening, guys. My name is Yuta Kariyado from University of Aizu in Japan. Then the co-author, Professor Villegas and Mr. Arevalo from University of Aizu too. So before I start my presentation, I would like to thank you for inviting me to speak today. I'd like to talk about 3D cellular automata with spatialized sound. So this is the outline of my presentation today. I'm going to divide the presentation to 6 parts by the following. So first of all, I would like to introduce the 2D version of Cellular Automata to let everyone know about it. This is not my research project, but now I use Gori, that is software for exploring Conway's Game of Life. So this is a Gori, the software exploring the Conway's Game of Life. Then you can put the cell on this grid with drawing like this. Then you can push run. This is the life cycle and layer words such as birth, survivals, death. Then you can see the cells like this. Okay, this is the original Game of Life. Then, okay, let me go back to the presentation. There are 2 main aspects that I'd like to explain about this project. First, implementing Cellular Automata in 3D environments with Auralization tool. Second, exploring and storing new patterns of 3D Cellular Automata and their use for generating music in real time. Originally, we began this research to celebrate the 15th anniversary of Conway's Game of Life. However, during the development stage, we learned about the tragic loss of Professor Conway to the recent epidemic of COVID-19. This project is also commemorating his contribution and legacy. So I'm going to explain the method of implementation. We have developed this application in Unity. There are 2 reasons for that. First, Unity is a tool for creating 3D environments as well as games. Second, in most cases, Unity can deploy programs to merge platforms like PC, smartphones, PS4, etc. with same source, including desktop-based and VR headset-based applications. About Auralization tool, addition synthesis of sounds relating to the position of each cell can be considered as sonification. So about synthesis sound, we have prepared wave files were created in MATLAB like this. These files, tones, have different sounds corresponding to the position of cells. The spatializer implemented by Mr. Arevalo allows us to create spatialized sound at any direction. Therefore, these sounds are considered as auralization sounds. Originally, the Game of Life implemented in 2D grid. You can see the figure on the left, and as I mentioned before, so each cell in the Game of Life has 8 neighboring cells, and their state is generally called dead or the dead or alive are determined by the following rules in the next slide. First, each empty cell adjacent to 3 living neighbors is a live cell in the next generation. Survivors, every cell with 2 or 3 neighboring living cells survives. That is, it is a live cell in the next generation. Death each live cell with 4 or more living neighbors is gonna die. Yeah. In the case of 3D version of the game of life, I mean in our project, each cell has 26 neighbors, so the loose can be defined with 4 arguments. In this case, we put the L1, L2, L3, L4 in the range of 0 to 26. Almost same lures are there, but lures become richer than that of 2D one. In the case of Suntan model, cells have a capacity value which decides its next state. That is called the number of grain of sand, and it can pile before toppling them. Cells that have grains of sand from 0 to 3 are called stable in this model. However, cell has 4 or more grains, it's called unstable. If the cells are unstable, they will topple and increase the grain numbers of each of its direct neighbors by 1 plus 1. In the case of 3D one, maximum of capacity value is 6 because each cell has 6 directly adjacent cells in 3D grid. About color of cells, yes, we color the cells in the 3D version. And empty cell, I mean, the cell have no grain of sand. It's colored gray, and one red, orange, yellow, green, blue, purple, and cell have 6 or more grains. It's colored black, and it's colored to resemble a rainbow. So now it's time to demonstrate our project. So can you see the project? Can you see the program? This one. You can load a preset. Sorry. First, let me show the normal 3D GOL. There are many options there, but first, yes, I want to introduce Rocket preset. You can also see the preset here. These CSV files contains lure and initial conditions of cells. Then the choose Rocket preset, then push run. Can you guys listen the sound? Then you can also change the transition of speed, the range of 60 to 140. Like this. These 4 cells going up and down, and these look like a rocket, so that's why I named it. You can rotate all cells as a cube with mouse dragging, like this. If you choose sequential option, you can listen the audio corresponding to XY plane, like this. Then if you choose the periodic option, the boundaries are connect to opposite boundary. You can also see different transitions. You can define the lures with given 4 numbers as I mentioned before. So let me put the lures 4, 5, 5, 6. Then, sorry. I generate a random preset. So yeah, you can change the lures in real time. So next, let me explain the Suntan model. The Suntan model has different options, but yeah, you can see the same options like back and sequential, run, random, and BPM slider, something like that. But you can set initial cell with given grain of sums. Like, so let me put that 2 on a 2, 3, 4, and with 36 lanes. Then you can set the cell and push run. It becomes unstable and it's going, finally going stable. And you can clear. Then you can put the random cells with the grain that you defined, like this. That's all the demonstration of our project. So let me go back to the presentation. We have held an experiment to survey the immersibility of 3D game of life. Participants were experienced 3 presentations of game of life. Since one is a silence, this is control condition, parallel like chords, and sequential like a melodies presentation, and each also take 2 minutes. 21 students from the University of Aizu, and 16 males and 5 females, about 22 years old, with no apparent hearing issue that is self-reported. Permission for performing this experiment was obtained following the University of Aizu ethics guidelines. The subjective task was twofold. Rate in the scale from 1, that is worst, to the 7, that is the best. How immersive was each presentation, and how was the quality of that presentation? Finally, choose the presentation most liked. Here we have the result of immersion and quality of 3 presentations. Statistical analysis of these data were done in R. Each result shows no significant difference on immersibility and quality between parallel and sequential presentation. In addition to the result, 13 participants preferred sequential to parallel presentation. So I'd like to summarize the main findings of this study. We've implemented 2 models of Cellular Automata in 3D environment. It can be said that we have archived the goal of improving the sense of immersion that was originally planned in the research. In the future work, we can implement another model of Cellular Automata like long-tongue ant, and also implementing other sounds like such as drums could show interesting results. Meanwhile, we have the limitation of this program 8x8x8. So the most important task is to accept this limitation so that infinite space can be explored. So thank you all for listening. Once again, it was a pleasure being here today. So I'll do my best to answer the questions. And also you can download the program on GitHub from this link. Thanks so much.
Okay, I'll ask a quick question. I'm just interested if you looked at some of the other work in music and cellular automata, because obviously there's quite a lot. I don't know if you're familiar with the Wolfram tones, which is the 1D CA. Did you kind of look at any of those other music cellular automata to compare with what you've done?
Yes. Sorry, I didn't catch what you mean actually.
Did you look at other uses of cellular automata in music? Like there's some well-known examples like the Wolfram tones.
I haven't seen before, but yes, I haven't seen before like this.
Okay, so thank you very much for the talk.